Hello, today we're going to be looking at how to verify that a point is a solution to a linear inequality graphically. Specifically today we're going to be using the Desmos online graphing calculator. So let's get started. First I want to do a quick review of what it means to be a solution, in this case algebraically. A solution is going to be any value that makes a statement true. So in this situation, -3, +2 is a solution to y is less than 3x plus 14, because as you can see, when I substitute those values in, I get a true statement at the bottom. 2 is less than 5. On the other hand, 5, -4 is not a solution to 2x plus 3y is greater than or equal to 6. Again, when I substitute values in, I get a false statement or an untrue statement. Let's see how that looks graphically. So we're going to look at a situation where we're looking at this graphically. Is -3, +2 a solution to y is less than 3x plus 14? Well, first I'm just going to graph this. So I'm going to go to my Desmos online calculator and graph y is less than 3x plus 14. Then I'm going to be looking for two things. Is the point in a shaded region? And if it is, the answer is a solution. If it's not, then it's not a solution. So when I graph, it's going to look like this. But where did that magic come from? Let's go click on Desmos and find out. So I'm looking at my Desmos. I'm using the North Carolina version, but any Desmos will work here. I'm just going to type in y is less than 3x plus 14. And you can see that it's created a graph for me where it's automatically shaded part of the graph. All of the y values that are less than this linear equation. Now to find the point, I can simply type in the point as well. That's -3, 2. And you can see clearly that it is a solution. It is inside. Okay, let's try another one. Is 3, 4 a solution to y is less than 2x plus 6? Go ahead to your Desmos calculator and graph this and see. Alright, so we're going to try that again. Y is less than. Now I'm just using the less than key. If you're unfamiliar with that, you can also come down here to the keyboard and choose the less than key. Y is less than 2x plus 6, and I'm looking for the point 3, 4. Let's see, I don't see it. Oh, there it is. Is the point 3, 4 in my shaded region? Why, yes, of course it is. So is 3, 4 a solution? Yes, 3, 4 is a solution. Let's try another. Is 2, 1 a solution to y is less than or equal to -1/2x minus 4? Again, go ahead and give this a try. Good, so you've given it a try. I'm going to go with y, and I definitely have to use my menu here for the less than or equal to sign. -1/2 x minus 4, and I want to know, is that a solution to 2, 1? Is 2, 1 a solution? Now, as I look at my graph, it's pretty clear to see that 2, 1 is definitely outside of the shaded region. So, is 2, 1 a solution? No, 2, 1 is not a solution. Notice on this graph there was a solid line. Let's see what happens if my point is not clearly within the border. What if it is on the border? Try this example on your own. Even though it's not written in y equals form, it's in standard form, I'm still able to graph this equation in Desmos. And you can see I have a dotted line. Dotted line for the inequality. When I type in and verify my point 6, negative 3, let's find it. There's 6, negative 3. So, interesting. 6, negative 3 is right on the border. Now, how do I interpret that? Is 6, negative 3 a solution? No. 6, negative 3 is not a solution to this inequality. Because it is on dotted line on the border, it means that only the values that are less than the line, not the values that include the line, would be solutions. In summary, as we're looking to verify a solution graphically, I need to ask two questions. Is it clearly in or out of the shaded region? Yes, it's a solution if it's in. No, it's not a solution if it's out. Or if it's on a borderline. If it's a solid border, then yes, it is a solution. And if it's a dotted border, no, it's not. Thanks for your time. Be sure to comment below